Hello, and welcome everyone to another remote CocoaHeads on this cold, wet March evening in Sydney. So let's get straight into it. We've got a pretty short one tonight, and as always, a reminder there on the screen that you can join in the discussions on Slack. We've got a Slack group. It's fairly active on the night of the meetup, so any comments or questions can be posted in there. And I believe Tom, our speaker for this evening, is pretty active in the group tonight. So if you've got any questions during his talk, he'll be around to answer them. So to begin, I would like to acknowledge the Gadigal people of the Eora Nation, the traditional custodians of this land, and pay my respects to the elders both past and present. Bit of housekeeping as always. So hey, we're your CocoaHeads team. I'm Zach. Unfortunately, we don't have Nikki on the call tonight, but we do have Carl. Hey, Carl.
Hi, everybody.
And as always, a big thank you to our sponsors, Billu and Atlassian, who help make nights like this possible. Now, as a reminder, Sydney CocoaHeads has a code of conduct, and this applies to all parts of the community, whether we're meeting in person, online, or whether we're just talking in the Slack group. You can read the code of conduct in full on the website there, but it does boil down to 3 key points. They are be respectful, be inclusive, and be aware. If you have any questions about this, or if you'd like to raise a concern, please do so with myself, Carl, or Nikki, and we'll take that on board and address it as best we can. I did mention it at the top of the call, but we have a Slack community. Again, there's the URL. If you'd like to join, feel free to take a screenshot and join in the discussions for tonight. Normally, when we meet in person, we welcome the first-time attendees. A little bit harder online, but if you are joining in for the first time, maybe you're not even watching from Sydney, big welcome. It's great to have you. We're a bit short on events to promote at the moment at this time of year. Not really sure what the rest of the year looks like, but I did, as always, want to call out Melbourne CocoaHeads. They do a fantastic job. They run in a very similar format to us. Their meetup is on the second Thursday evening of the month. We're on the third, and they usually have a couple of great talks as well. So if you like what you see here tonight, definitely check out Melbourne CocoaHeads. They're running online as well at the moment, and I assume for the foreseeable future. So everyone is able to join in there, which is really cool. If you are looking for work, or if you know of somewhere that's hiring and you'd like to promote it, feel free to jump on over to the jobs channel in the Slack group and post about it there. We often have people either looking for work or looking to hire, so that can be a great place to find candidates or fill roles. Optus is looking for an iOS developer. Got some contact details up there if you're interested in working at Optus. I will leave that slide on the screen for the next few seconds. You can take a screenshot if you might be looking for work. Alrighty, so let's get into the plan for the rest of the night. I did mention it's going to be a short one. We've got a month in review, which not a whole lot happened in this in the tech world over the last month. So I'll be keeping that one pretty short. And we've got one talk from Tom tonight from Bare Feetwear, and it's part 2 of his talk from last month, building an app like Lego with Swift UI. You can catch the first part of that talk on our YouTube channel in the replay of last month's event. But tonight we have part 2, so very much looking forward to that. And then, of course, after we have our post-Zoom catch-up, I'll be posting a link to the Zoom call in the Slack group at the conclusion of this YouTube live stream. Feel free to join. Anyone's welcome. Have a chat. Catch up with people from the last month. That'll be good. And looking forward to next month. So April, we're looking for talks. We currently don't have any talks lined up. So if you have something you'd like to talk about, please, we highly recommend submitting a talk or getting in touch if you've got any questions about that. I'm more than happy to workshop ideas if you want to run some by me. That's more than welcome. And also, we're looking for someone to do the month in review if possible. We are still running CocoaHeads online for now, but we're constantly reevaluating this. And I think now's probably a good time to mention that if your company has a COVID-safe space and you might be interested in hosting CocoaHeads in the coming months, please feel free to reach out to Carl or myself and maybe get the ball rolling on some in-person meetups. No promises yet, and we'll give everyone ample notice, but the plan is to at least start discussing our options for the next few months. Should be good. It'd be great to run in person again instead of just talking to my computer. All right, so month in review. Let's get straight into it. Not a whole lot has been happening. I was really hoping that I'd be able to mention we have the dates for WWDC by now. No announcement as yet. Probably expecting that around June sometime, but as of the time of recording, there's no mention of when WWDC will be. But I think it's pretty safe to say it'll be online. Again, it'd be interesting to see exactly how it differs from last year, but I thought the format was pretty good. So I'd be expecting something similar at least. We can finally say goodbye to BuddyBuild. This is not very exciting news. I quite liked BuddyBuild before it was acquired by Apple. It's been really quiet since then with heaps of rumors about, maybe Apple's going to launch their own CI service or what else they could possibly do with BuddyBuild. But it seems like BuddyBuild's days are finally over. I feel like we've had this kind of discussion a few times since Apple acquired BuddyBuild. There's been some hiccups along the way, them not announcing anything at multiple WWDCs, and then I think the CEO left, like the original BuddyBuild CEO left a little while after. But yeah, here we are. It looks like Apple is properly shutting down BuddyBuild, and all of those users whose accounts have still worked since the acquisition. That's not going to be the case anymore. So, RIP BuddyBuild. Really light on news this month when this is the kind of stuff I'm talking about, but it seems like Apple has started policing in-app purchase subscription prices. There's been some chatter on Twitter around scam apps lately and apps that might try and trick people to place their thumb on the fingerprint reader to scan and approve an in-app purchase, or that rip off another app and look very similar, and instead of confusing people into downloading and raking in hundreds of thousands of dollars a year and things like that. But the follow-on from that, and the follow-on from a bunch of those scam apps, being taken down after charging ridiculous prices, is that it seems like some genuine apps too are caught in the fire of this, and that some apps have been told your subscription pricing might be a little bit too high. You might want to reconsider that. So something to keep in mind when you're deciding to price your app. It looks like Apple's getting involved on whether a price is acceptable or not. This is a big one. I don't think I mentioned it in the last month in review, but I think Xcode 12.5 was in beta at that time. But anyway, XC test and UI test are now available for watchOS targets, which is really awesome, because up until now, if you've wanted to test your watchOS only code, you've had to jump through some hoops, and it's not really been a first-party supported feature. So it's really good to see this. And then a series of things which we can say goodbye to. So goodbye to the iMac Pro, who was discontinued. I think it'll be really interesting to see what an Apple Silicon-based iMac looks like, presumably later this year. I'd expect to see some details, but unfortunately, the iMac Pro itself has been discontinued. And the HomePod's also been discontinued. That's the big one. The Mini's still around without a regular HomePod to complement it. But yeah, goodbye HomePod. It's no more. You can't really buy them anymore. So there's that. All right, that's all from me. I said it'd be short. So now we're going to jump straight into Tom's talk, building an app with Lego. Building an app like Lego with Swift UI. And here we go. Thanks, Tom. Let's get started.
Hey, everyone. Thanks for coming by to listen to my talk. This is part 2 of what I started last month. It's just a very short talk about aligning views using Swift UI. Now, you'll remember, if you were there for the talk last month, that we went through fairly standard assembly of a view of a scene, which you can see on the right there. We use this for measuring electricity from solar, battery, and grid. And it's just made up of V stacks and H stacks. You can see the different cells there. Some of them are different heights according to their content. They have section headers. That's all pretty standard. And we went through that in detail last month. And at the end of last month, I said, but what if, in addition to having the V stack on the right-hand side, if we wanted to align something to that on the left like this, the difficulty then is the right-hand side is auto laid out by Swift UI, but it doesn't really easily give us the location of each of those bars so that we can align our new view on the right. And I asked us to imagine what that might be in Lego. And here it is, assembled using Lego pieces. And I use Lego as an analogy just because it makes it easier to understand the concepts of building stacks and aligning things. So again, if we imagine what it would be like if we needed to add the connections on the left-hand side, then it might connect to our Lego something like this. And for that, we would need a base plate onto which we can stick our Lego pieces. And about this stage, I realized that the dark mode Lego doesn't really show very well on the video. So I'm just going to switch all my Lego to light mode. Hopefully that's a little bit easier to see. And let's pull all that apart, all the Lego pieces, so we can see how we might need to line this up. So if we move that plate on the left, which I'm going to call the channel, and we remove the cells in the middle, move those out, which I've called bar cells. And each of those bar cells consists of, you can see an H stack at the top that's got like the sun and solar and text, and it has a bar. So each one of these has a bar at the bottom. So if I want to align each of these connections to the bar, I need to know the location of that bar. I also want to align this circle here, which represents the inverter in a solar system. I want to align the top of that to the top of this card here. And for this talk, I'm just going to talk about that because the principles that I outlined for that are the same principles that I use for the more complex, well, what might appear to be more complex problem of aligning these, but it turns out it's exactly the same. So let's look more closely at aligning this inverter, the top of the inverter to the top of the card here. So put all those back. All I care about at the moment is just the position of that top of the circle. Now you might remember from last month that we developed a code like this. So this is the code for the cards, which is this right-hand section. Again, it's just a VStack with different sections. And inside the VStack, we've got some cards here. So you can see there's a loop of the circuits, which is this section here. Then there's the home card, which is this one here, and that's the one where we want to align the inverter just here. And then we have appliances down here. So if I refactor our code, which I think we did last month, and pull cards out of the body, then all we've got left in the body is just the card. So this is what our code looks like as we left it at the end of last month. Now, in order to have this channel on the right-hand side with the inverter and so on, we're obviously going to need an H stack. So let's add an H stack. Now we've got our channel on the left-hand side. So here I've just called it channel. I've put it inside an H stack, and for the moment, I've just made it a color, and I've just given it some opacity so we can see anything that comes through it. And we're going to make this a fixed width that we're going to get from our view model, but obviously we could hard code this here or put it as a let inside our view, but let's do some good architecture and have it stored away in a view model. And this channel we need to build up with those sort of three sections. So if we build the channel up with a VStack, similar to what I did in the Lego, I'm going to have a color rectangle here, and then my inverter, another color rectangle here. Now, if I do this just using Apple's default layout, as you can see, it's just going to equally space them. So this inverter here is just in the middle, but it's not where I want it to be. It should be up here, but it's here. So how can I, this is the essence of the problem. How can I make this line up with this? Now you might sort of at this point think, oh, well, instead of putting it all in H stack, maybe put the whole thing in a V stack, make this part of that, but it just becomes a mess for other reasons. So we really want to keep this as its own V stack and just find out where this card appears so that we can align this. Now, what we're really after is to be able to, for this inverter view here to be in the right position, is we need to have the color section above be a particular height. So we might be tempted to just put in a frame with a particular height here, and that would be a magic number that would just give us exactly what we want. But of course, that's only going to work if this font never changes, if the text never wraps, if the user doesn't increase their font size, or a myriad of other situations. The screen might be split screen and shrink, they might rotate the device, anything could happen. So we need to do this programmatically and not have a magic number here. Now, ultimately, what we need to use to do this is to understand that iOS has a coordinate system that starts in the top left, 0, 0 coming down. So if we look at it like that, here's our card, our home card, and we want to align the top of this inverter view with the top of this home card, which in our example here, the magic number there is 313 points. And this card here is in code that we looked at before, is this bit here where we've got our home card wrapped in a card, and that's providing the padding and the rounded corners and the white background and so on. So the question is, how do we get the coordinates of this card and then pass it on to the frame of this inverter view? Here it is without all of the other code. We're just zeroing in on how do we get this card its position. What we really need to do is somehow read the bounds of that card. If we can get the XY origin and the size, then we're on the right track. So it would be great if we could just do this. If we could just say, look, read the bounds and of this object and put the bounds in whatever function we provide here. So here I'm just assigning a var called home card bounds, which has an initial value of 0. And if this magical read bounds function can get the bounds of this view, then we can send it to this function to set it. I should point out at this point that the reason I'm using the word bounds and not frame, in UIKit, technically this would be called a frame, because a frame gives you the coordinates of a view inside its super view. But unfortunately, frame is already used in Swift UI to specify the location of an object, which isn't the same. It isn't a CG rect. So I've had to use the word bounds just to kind of make it clear that for bounds, I'm talking about get the coordinates, which is the CG rect of the object. So if we've got this magical read bounds function, then that means that this line of code would get that value, and then we can use that in the channel in place of our magic number that we saw before. Instead of 313 here, we can now have the view model home card bounds and get the minimum Y of this bounds, which is this distance here, and that's fantastic. That does exactly what we want. Job done. But as you might have guessed, or you might already know, there's just one problem with read bounds, and that is that it doesn't actually exist. There is no read bounds function, but we can build it ourselves. So let's have a crack at doing that. So it's going to look something like this. We're going to need a function that's an extension of view, because the way we used it was to say dot read bound something on a view. And we need to pass into that a function that takes a CG rect parameter and doesn't return anything, but does whatever that function requires it to do. In our example before, we're just going to put in a function that, or a closure that's going to take the bounds that is provided and store it in a var, but the function might do anything. So if we're thinking about this procedurally, which isn't the way that Swift UI works, we might think that what we've got to do is we've got to get the bounds through some magic to get the bounds of myself, because remember, this is a function on the current view. Then execute the writer function, which does whatever the writer function decides to do with those bounds, and then return a view, because this is a function that needs to return a view. So let's sort of figure out how that looks in SwiftUI and not so much procedurally. And the way we need to do it is for to get sort of the size or other geometry of a view, as many of you would already know, we need to use a geometry reader. And if we've got a view, in this case, this card here, an easy way to get the geometry of itself is to get the geometry of a background of self, because the background will always take exactly the same coordinate rectangle of self. So just doing this, just putting a background on self and then putting a geometry reader on that background means that this geometry will be the geometry of self. And then I can, because I'm doing a background here, it has to be some sort of view. So for the moment, I'm just going to put a pink color, which effectively is a rectangle, that's going to completely fill the bounds of self. And I'm making it pink at the moment just so I can see what's happening. Ultimately, I want to make this clear. But I still need to somehow execute the writer function. So this will get the geometry, but somehow I need to get the bounds of that geometry and give it to the writer function that I'm provided. Now, I won't go into the detail, but the magic required to do this line is to use SwiftUI's preference and on-preference change. So basically, for preference, you say, look, here's a key, and the key is going to be I need to provide something that conforms to the preference key protocol, and I pass that whatever value I want. And then the on preference change watches to see if this view changes size or changes anything that's going to adjust the preferences. So if I make my own protocol that conforms to this, I'm going to call it bounds preference key, because ultimately it's going to be a protocol that will provide the bounds. And this is pretty much boilerplate. If you were doing something other than bounds, you would change the type from CGRect and the type here and so on. But basically, the way the preference key works is it just needs to know, look, I've already got a value. What should I do with the old value compared to the new value? And this is just basically saying, ignore the old value and just make the new value the one that's provided. So like I said, this is pretty much boilerplate, but in essence, what's happening here is preference and on-preference change using this bounds preference key is just going to provide a value for our writer bound. So it's just going to provide the rectangle of whatever function has read bounds applied to it. So this all works as is for every view I give it. I don't have to customize it any further. So let's have a look. And one other small thing is that geometry doesn't have a property called bounds, which, as I mentioned before, there's kind of a discrepancy between bounds and frame and what each of those mean. And in this context, what we really need to provide is the frame, not the frame as we usually see it in SwiftUI, but as a property of geometry, it is actually a rect. And so we need to provide frame. And if you type .frame, you will get an auto completion that requires a coordinate space. So we need to provide a coordinate space. And that makes sense because are we talking about the location of this subview within this section? Or are we talking about its coordinates in regard to this entire view or some super view beyond that, or the scroll view, or whatever. So we just need to be explicit about which coordinate space. And that's why I've got here from the outset that this is going to be my coordinate space. But from this function's point of view, I really want the caller of this function to provide the coordinate space so it's more usable. So let's change read bounds to allow a coordinate space to be passed in, and then we can just put the coordinate space here, and now it's all happy. And we might just simplify it a bit and get rid of this self dot. And since we've just got this bounds variable used once inside the closure, I'm just going to replace that with a $0. So there we go. Here's our template code. The only thing we will change later is the color pink will change to color clear. But this can be used again and again just as is. Let's have a look at how we use it. So back in our cards, that little section that we had before, you remember we made up this read bounds function, which didn't exist. Now we've actually made it exist. But as you've just discovered, we also need to provide coordinate space. Let's add coordinate space to that. So read bounds will now take in a space. So we need to define what that space is. So again, within this Swift UI view, I'm going to define a variable called space, which is going to be coordinate space. And I'm going to get the name from my view model. And it doesn't matter what you call it, as long as you use the same coordinate space name for when you read as when you write. So here we're reading, and here I need to specify, and somewhere I need to specify where the coordinate space is defined. So you apply it to some super view. So here I'm applying it to the entire body. So here I'll say the coordinate space called live flow view is defined as being this whole thing, which means in my drawing here, this is where it's applied. And so whenever I choose read bound in that particular space, it knows that this is the origin and I need to know the location with respect to that origin. So that will work well because both of these, the home card where I want to read and the inverter view where I want to use it, are both in that coordinate space. Now you remember we had that pink overlay, and the reason I had that is because when I actually run this code, even in the simulator, even in the preview, you'll see that it actually applies the pink. You can see it just peeking behind the card there. It actually applies the pink to any view which has read bounds applied to it. So I can see that it has read this particular card. And in fact, if I apply it to all of the other views whose bounds I need to read, then I get this. So I can see this shows me all of the views that in my code I've applied read bounds. So I've applied read bounds to this cell and this cell and this cell and this card and so on. And that, as you might recall, oh, well, first of all, let's remove the pink because we don't want that at runtime. So I'll just change the pink to clear. And so now we don't see anything, but it's a very handy way to get it back. And you'll recall that the things that I had highlighted in pink here correspond to in Lego when I separated all of this out. So these were the different subviews that I needed to interrogate to find out what are the bounds of those subviews so that I could do some calculations. So back to reading the bounds. Now we're in a situation where we've got everything we need, I think. So we've got this home card here, and here we're reading the bounds of that home card. We're putting it into a variable that I put in the view model up here that's called home card bounds. So as soon as this executes, it will set the home card bounds of the view model to be whatever the bounds are of this. And now instead of the magic 313, I can now set the frame height of this yellow here to be the same as the minimum Y of this. And that means that the next object in the VStack, which is the inverter view here, will be exactly where I want it. Now, ideally, I wouldn't be putting calculations like this, view model.homecardBounds in my view. I would actually move that calculation to my view model, as simple as it is. But as you might imagine, some of these other calculations are a bit more complex. So it's best to put all our calculations in our view model. So that's it. That's the problem solved. I hope you all enjoyed that. That was something that for weeks, if not months, I kept putting off as a problem I needed to solve. It came up a lot of times where we've had something, a scene where we've had two different views, and somehow we needed to find some correlation between them, whether it was a chart or whether it was just a sort of fancy animation like I showed you a minute ago. If you have any questions, I think we're hanging around afterwards for a chat. And you can also grab me on contact details there via email or via Twitter. And if you've got any Swift UI projects or you're looking to incorporate Swift UI where you work, then have a chat to me about perhaps coming and training up your team. All right, thank you very much. Chat to you later. Bye.
All right, awesome. Thanks for that, Tom. That was a great talk. As Tom mentioned, he's around in the Slack if you've got questions, and also will be on the Zoom catch-up post meetup. So I'm going to go ahead and post that Zoom link in the Slack group, so feel free to join. And as always, looking for talks for next month. So if you're interested, please just give me a yell. Otherwise, hope everyone has a great month, and we'll catch you in April. Thanks.